Hi, Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we're now in lecture 204, and specifically it's for Poisson distribution. Okay, it's still in topic 10, special probability distributions. Okay, so now we will look into the identify the Poisson distribution. We write down in this recall node of Poisson with the recall parameter of lambda, and we're going to identify the mean and variance and use in the solve related problems. Okay, sorry. So the Poisson is used to model situation where random variable x is number of occurrence of a particular event over a given period of time or space. Okay. So examples: when a telephone calls made to switchboard in a given minute. Okay, telephone calls is also related with the time. Road accident a particular motorway in one day, and also we call loss in a meter of fabric, the space there. Okay. So the probability of that number of occurrence x over a given period of time is equal to x is given by this one here. Okay. So this is the formula if we like to solve or find the answer using we call calculator. Okay. And we have two options, whether use the calculator using the formula or using the statistical table again for this one. Okay. And then where lambda is the average or mean number of events that occur in that interval is set. Okay, so we write down as an x Poisson distributed with the parameter of lambda. Okay, and as we know that the summation of all the probabilities are all equal to 1. And if we use the formula we call if we use the statistical table, okay, and if you refer to the value of r, so it is refer to the probability of x greater than equal to r, where x is larger and equal to r. So just like the binomial, we call the value that is the probability that you see in this box here is related. We call is for the probability of x greater than or equal to r. Okay, for lambda is 7.6. Okay, is greater than for probability of x greater than or equal to 2. As you can see here now. Okay, so look at this. It made here. So it is 0.09957. Then the probability of 2 or more events occurring is 0.9957. There we see that. Okay, example 1. So find the probability of this. So for probability of A, probability of x greater than or equal to 0, and for this one we come up with probability of x greater than or equal to 0 minus probability of x greater than or equal to 1. Okay guys, girls, we shall do the first for the first example here. We're going to use the formula and using calculator to get the answer. Sorry. Okay. After this, there will be example that we're going to use the statistical table to get the answer then. So now property of x equal to an x equal to e power of negative lambda multiplied with lambda to the power of x divided by x factorial. Okay, so in this case, this is your lambda, which is 3.5, and then x according to the value of this. Okay, so the first one here, property of x equal to 0. So then this is your x now for this, and lambda is 3.5. So e power of negative 3.5 times 3.5 to the power of 0 divided by 0 factorial, where 0 factorial equal to 1. So then, use the calculator then. Okay, e to the power of negative 3.5, okay, multiplied with 3.5 to the power of lambda of x, which x equal to 0, and divided by 0 factorial equal here. Okay, let's see what we got in here now. Okay, it is 0.0302. Okay, so for this one here now is 0.0302. And what about B? Property of x greater than or equal to 4. Greater than or equal to 4 means that okay, for this one, which I think that we straightly use the statistical table. Okay. For Poisson distribution, it begins with page 10. Page 10. Okay, page 10 here, where lambda is 3.5, turn to page 12. Okay, turn to page 12 here. And r equal to 4, 3.5, and r equal to 4. And r equal to 4. Okay, so look at this one here now. This is lambda equal to 3.5. Okay, here, and r equal to 4. So we get it here now. It is 0.4634. Okay. C, property of x less than 4. Okay. The reading in this statistical table, it gives us the property of x greater than or equal to r. So for this one here now, x less than 4 meaning is property of x equal to 0, x equal to 1, x equal to 2, and x equal to 3. Okay, does not include 4. So what we can do here now is we come up with property of 1, because again the summation of all the probabilities of x equal to 1. Don't forget this. Okay, so 1 minus property of x greater than or equal to 4. We already found an answer here, so we can strictly use this 1 minus 0.4634. Okay, sorry. (0.4634), then 1 minus that equal to 0.5 3, 6, 6. Okay. Then next, probability of x for D. For D here, probability of x less than or equal to 2, including 2. Means that if we wanted probability of x equal to 0, x equal to 1, and x equal to 2. Okay, you may use this one by one, starting from x equal to 0, and x equal to 1, and x equal to 2. Okay, but then, make our life easier, just come up with 1 minus probability of x greater than or equal to, okay, it is equal to, so we begin with 3 here. Okay, so it is 1 minus 0.6792. I show you recall once or 2 times on how to find the recall, the probability inside the statistical tables. Okay, so the rest of it you find out yourself. It is for this one here now is 1 minus 0.6792. Okay, it is 0.3208. Okay, and what about this one here now? Probability of x in between 2 until 5. Okay, it is include 2 and also 5. So we come up with probability of x greater than or equal to 2. Because it's include 5 here, so we minus probability of x greater than or equal to 6. Okay, so just imagine that if this is the block that I used in here, okay, it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so probability of x greater than or equal to 2. From 2 here, minus probability of x greater than equal to 6. Begin from 6 here. So what we get then? We will get probability of x starting from 2 until 5 here. 2, 3, 4, and 5. Okay, so for this one here now, probability of x greater than or equal to 2. Yet, we call the parameter of lambda is 3.5. It's still in page 12. Okay, still in page 12. Okay, sorry. Okay, still in page 12. And then x r greater than equal to 2. Look at 2 here. Okay, look at 2 here. And then find where they intersect with 3.5. Okay. From here, it gives you 0.8641. Okay. 0.8641 minus, and for x greater than equal to 6, 0.1424. Okay. 1424, and get the answer of this one here. It gives us 0.7217. Okay. The next one, okay, between 2 and 5. Last final one then, E then. Probability of x 2 and 5. Okay, this including 2, but does not include 5. Which means that we're talking about the probability of x equal to 2, 3, and 4. Okay, so we come out with probability of x greater than or equal to 2 minus probability of x greater than or equal to 5. Okay, again, zero, 1, 2, 3, 4, 5, 6, 7, and so on. Okay, for x greater than or equal to 2, meaning we call starting from 2 here minus x greater than equal to 5. So you can see here now, okay, no, sorry. Then we'll get the value from x equal to 2 until 4. This one came from 2 but less than 5, which means that added 4 here, 2, 3, and 4. Okay, for this one here now, you may certainly get it from answers then 0.8641 minus here is 0.2746 equal to 0.5895. Okay. The number of telephone calls made to a switchboard during the afternoon call can be modeled by Poisson distribution with a mean of 8 calls per 5 minutes. Okay, 8 calls lambda here equal to an 8 in 5 minutes. Find the probability that the next 5 minutes no calls is made. Okay, so for this one here, probability of x equal to 0, which is e power of negative lambda, lambda equal to 8 negative lambda, and 8 to the power of 0 divided by 0 factorial. Okay, so for this one here now, okay, e power of negative 8 and then 8 to the power of 0 factorial. Okay, so this is what I get here now, and the answer is, okay, and this, okay, it is 0.0003. So 5 calls are made. Okay, sorry. For question B, okay, so probability of x equal to 5, then we come up with probability of x greater than equal to 5 minus probability of x greater than or equal to 6. So get it from this, we call this statistical table books here. Okay, so 3.5 r equal to 5. Okay, it's between 3.5 here. Okay, 3.5 here. And then we'll refer to the value of r equal to 5 and r equal to 6 down here. Okay, r equal to 5 and r equal to 6. Okay, so if x equal to 5, 3.5, or x equal to 5, sorry, okay. It's not a page of 12 anymore. It's page of 13. Okay. Page of 13. The lambda equal to 5 here. Lambda equal to 5. And refer to the value of r, which is 5 and 6. 5 and 6 here. So 5, it is 0.5595. Okay, sorry, I'm make a mistake because I can refer to the books properly then. Okay, because the lambda equal to an 8. So turn to page 14. Okay. Turn to page 14. Okay, as you see the 14 here now, page 14, and then the value of lambda equal to an 8. The value of lambda equal to an 8, and r equal to 5, 0.9004 here, and 6 is 0.8088. Yeah. Okay, so this one will give you 0.9004 minus 0.8088. Okay, so this one here now referring to the lambda equal to an 8 and r is 5 and 6. So from here now I give you 0.0916. There you go. And for question C, at least 3 calls are made. At least 3 calls, it is property of X. So the least call here is 3. So it can be 4 or 5 or more. So at least we call at least 3 calls. Then again the lambda equal to an 8 and r equal to 3. Lambda equal to an 8 again here. Lambda equal to an 8 and r equal to 3. Then it gives you, you see here, 0.9862. 0.9862, and it is here. Okay, and D, probability of X less than 4. This is for probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to 2 plus probability of X equal to 3. Okay, so then does not include 4. So the summation of all the probabilities equal to 1. So for this one here, we come up with 1 minus probability of X greater than or equal to 4. So 1 minus probability of X equal to 4. Lambda equal to 8 and r equal to 4 here. And lambda equal to 4, and the value here is 0.9576. 0.9576 equal to 0.0424. Okay. The next question. Okay, the next question. Less than 4 calls are made. Between 3 and 5 calls. Between 3 and 5 calls are made. E, number 1, probability of X between 3 and 5. So does not include 3 and does not include 5. The middle of this between 3 and 5, which is 4, probability of X equal to 4. And we can find this using probability of X greater than or equal to 4 minus probability of X greater than or equal to 5. Okay, so for this one here now, this is straight get from we call the statistical table. 0.9576 minus this one here, 0.9004. It is 0.057. And number 2 here, between 3 and 5 calls are made inclusive, meaning including 3 and 5. So between including 3 and 5, so we come up with probability of x equal to 3 x greater than or equal to 3 minus probability of x greater than or equal to 6. Something like this again. Okay, all the blocks here 0, 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so probability of x greater than or equal to 3 begin with 3 minus probability of x greater than or equal to 6 here. So you can see here now, we will get exactly, we got the probability of x from 3, 4, and 5. Okay, so this one you can certainly get it from the books, which is equal to 0.9862 minus 0.8088 equal to 0.1774. Okay. Example 3, the number of industrial injuries per working week in a particular factory is known to follow a Poisson distribution with a mean 0.5. Okay. Find the probability that in a particular week there will be less than 2 accidents, more than 2 accidents, there will be no accident in a 3-week period. Okay, class. Okay. From the question, we mentioned that the number of industrial injuries per working week. Okay, per working week in a particular factory is known as follows Poisson distribution with a mean of 0.5. Okay, so for question A, for this and this, we use the lambda as a 0.5. But then for question B, because this 0.5 in per working week, in 1 week. But then when it comes to question B, in a 3 weeks. So there might be a changes of value of lambda here because this is for 1 week. So for 3 weeks, it might be, okay, I guess it might be something like this. 3 multiplied with 0.5 is 1.5. The new lambda, which is not lambda that we got from the beginning. Okay, for question of B. Let's try. Okay, the first one then, x Poisson distributed with lambda is 0.5. So then, the first question, find the probability that in a particular week there will be less than 2 is accident. For A1, okay, for A1, probability of x less than 2 accident. Less than 2 for this one here, which is probability of x equal to 0 as probability of x equal to 1. Okay, if you use the formula, if you use the table, so we come up with probability of x greater than or equal to, 1 minus probability of x greater than or equal to 2. Okay, so from here now, 1 minus, okay, this one here, lambda is 0.5. 0.5, turn to page, okay, turn to page 12. Okay. Page 12, for lambda is 0.5 here. Okay, 0.5 and x are equal to 2. This is page 12, where lambda is 0.5. Okay, 0.5 here, and r equal to 2. Okay, so when we intersect each other, 2 and 0.5, it gives you 0.0902. Okay, so for this one here now, 1 minus 0.0902 equal to 0.9098. Okay, the next question then, more than 2 accident, x more than 2 accident. So again, for this one here, for discrete, because it does not include 2 here, so after 2, and they come up with x greater than or equal to 3. Okay, still the lambda is 0.5, and using the r, which is equal to 3 here, okay, 0.5 and r equal to 3. 0.5 and r equal to 3. So then make here it is 0.0144. Okay, so it is this one here, 0.014 and 4. Okay. For question B, because there will be no accident in 3-week period, this value of lambda is 1 for 1 week period, but for 3 weeks period, so then the new lambda comes with 3 multiplied with 0.5, which is equal to 1.5. Okay, so therefore it's now is a Poisson distributed with a new lambda parameter here is 1.5. Then probability of x equal to 0. Using the statistical table, it is probability of x greater than or equal to 0 minus probability of x greater than or equal to 1. Okay, so 1.5 still is the same, page 12, but then the new value here. Okay, 1.5, and then 1.5 x equal to 0. X equal to 0 here. It is for this one 1.5 x equal to 0. It is 1. Okay. Minus x greater than equal to 1. 0.7769. 0.7769, and it gives you 0.2231. Okay. Mean and variance of Poisson distribution. If x is Poisson distributed with a parameter of lambda, then the mean is lambda itself, and the variance is also the variance of Poisson distribution, also the lambda. So quite easy, because the parameter we call also represent the mean and variance. Okay, if the random variable x Poisson with a mean of 9, find the ex. So this is 9. Okay, variance is also 9, and for this one C here, for C, probability of x less than 4 equal to probability of x x less than 4, meaning is for x equal to 0, x equal to 1, x equal to 2, and x equal to 3. Does not include 4. So it comes out with 1 minus probability of x greater than or equal to 4. Okay, and for this one here now, please refer to your statistical book. This gives you 0.9788 equal to 0.0212. The number of phone calls received by a household each day over a period of 300 days was recorded, and the result was as follows. Okay. 121 days, there's no call. Okay. Let's say in my house, okay, I receive a call for over 300 days recorded, and result here. For 121 days, there's no call at all. 110 days, one call. And 50 days, I got 2 calls and 3 recalls. 16 days, I got 3 calls per day, and so on. Okay, so now for this one, EX mean equal to 0 multiplied with 121 plus 1 times 110 plus 2 times 50 plus 3 times 16 plus 4 times 3 plus 5 times 0 plus 6 times 0, and everything, all this divided by 300 equal to 0.9. Okay, so the question then, find the mean and variance. So mean is 0.9 and variance of x is also 0.9. Okay, so this is the conclusion for Poisson distribution, and these are a few exercises for you to try, and I do hope that my explanation helps you to understand the content of this topic and continue with your tutorial and past year questions. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.